right, let's see what we have here. So we have this interesting little setup here. And what we want to do is we want to create all these parts and then use constraints to assemble them together. And we're given all the details of the parts here. So let's see what we need. We need these spacers and all these other parts. All right, so we'll start with a spacer. Let's get a sketch going. Now the spacer we have here has 3 holes. What we're looking for 4, so we'll just add to it. So this is 90 in length, and these are spaced 30 apart, so we want to have it 120. So we want something that is 120 in one direction, and if we look there at 30 in the other direction. Zoom to go out. So now we can just extrude it and put holes in it, but we can also just put the holes in right away. If we start down here, it's going to be easy to figure out exactly where that hole has to be. It says, 15 from both sides, so we can kind of go in here and say we want to have 15 and okay, minus 15. That's fine too. And then the size, it says diameter of 10. Very good. And then we'll use our pattern, rectangular pattern, to get everything where it needs to be. We want this as our direction. It's already pointing in the right direction. We need a total of 4 holes. And there we're supposed to be 30 millimeters apart. That looks good. So we'll say finish. And now we can extrude this up to 10. Thickness of 10. Already has 10 on there, so that's all good. We have this part, so let's save it. Let's see if we can find the right else would be assembly. And we'll call this the spacer. Save. And then we'll need a new part, so a new file. You think that it goes back into the same folder, but no. Assembly and example 2. I think we put stuff in the wrong file. Let's create a new folder here. Do example 2. I think we're doubling up on stuff here, so we will save this one as a spacer. I'm getting confused. Let's do this again. Let's do save as. Not example 1, but example 3. Spacer. There we go. Now we'll create a new other standard millimeters. We want to do this. So we'll do kind of this outline and then extrude that. Put the holes in. So that would be here. We'll go there once around. So that be going to start with a line that's 40 in this direction. Go 0. Click here to zoom. And then it says 40 from the corner to there, but we have another 10 to go down, so 50 in total. 50. And then it says 40 for the entire inch way out, but we're here, so we only need 30. 30, and then 10 is the thickness, and then we already said the one going back there is 40. Going down is 40. We did something wrong somewhere. Let's put this in somewhere. Where is that? 50 there. That's what the problem is. We'll do this one as 30 as it's supposed to be. That makes sense, but let me see. I think I must have mistyped somewhere. So let's go into here. This is not 50, that is. That is 50. Where am I going wrong? 40. Oh, it's just 40 because I'm not going all the way up. Thought wrong about this. Now we have the right shape. Now we can extrude, see the whole thing. And how far does it get extruded? Gets extruded by 30. Very nice. All we're missing are the holes. So let's do some sketches. New sketch, circle on the halfway point, and we're supposed to be 15 in. So let's just do one here. Size is 10. And then that's dimension to the halfway point here. And that says there is supposed to be 15. Finish. Do our extrusion. And we want the through all right there. Our next sketch can go right there. Now it is 15 and 15, so maybe we can find the spot directly. We have the 15 in X, 15 in Y, not 5, 15. And then size 10. All right, another extrusion through all. Cut. All right. And then the last one. Halfway there, and another 15 in, I'm assuming. And we're here is 30. Oh, here is 30, yeah, so 15. This should be 15, 15, and 10. And again, we'll extrude all the way through. And there we go. Save this one. We'll call this the Z bracket. Z bracket. Very good. What else do we need? We need an L bracket. Is this just the Z bracket with the top cut off? 40 up. I think it is. Oh, not 100% certain. That's just simple enough part to draw. So let's just draw it. But otherwise, we might have been able to just cut off the top or something. But this is straightforward enough before we think for too long. Might as well just draw it. So 40 in that direction. And then 9 degrees, another 40 in this direction. And 10 here. That means 30 down. This looks very strange. 30 down and 30 across. This mirror does this look awfully strange. Something not quite right. Well, let's finish drawing and then we'll figure out what's going on here. This is 40. This can't both be 40. Oh, because we're looking at a weird angle, that's why. I'm wondering why it looks so straight. Now it looks good. Yeah, it's good to pay attention that stuff doesn't look the way it should look, then you have to go back and check why. Okay, that's a 30. And then our two holes, one here, this one. Circle is on the halfway point. So we have minus 15 and 15 and 10. And extrude. Right. Another one. These are halfway. So that'd be 15 here. 10. And extrude. And okay. So this we can do as the L bracket. L bracket. Save. And then we have one more. And that is the peg there. So it's supposed to be a length of 20. We have 10s and 10s everywhere. So let's do that. 10. Finish. Extrude. Thickness of to a height of 20. And we just save it. And we'll call that peg. All right, very good. So now we have all our parts. So now we can go create our assembly. We want standard millimeters and create. Start placing some stuff in there and we'll scroll up to here. This is how we want to create it. So we need a spacer. Actually, we need 2 spacers. Now, I'd like to have my correct view and flip this along the Z axis. So that kind of looks a little better, and we'll need a second one. Okay. And let's zoom out, and this is where we're gonna build our little piece. Let's remember that we want to ground this one so the stuff doesn't move around. Okay, that worked. Then we need the peg to connect. We need 1, 2, 3, 4 pegs. So we might as well just place them all at once. 1, 2, 3, 4. And okay, right? Remember, it doesn't matter what the orientation is there. We're gonna constrain them anyway. So an insert constraint. Insert that one there. Pull that in so we can see it. Need to flip it. And okay. Now we need 2 Z brackets. 1, 2, and okay. Another constraint, another insert. Flip that right away now. And we have that. Okay. Now this is still movable. So let's do a flush between here and there. And now it's no longer movable. Perfect. And then we'll keep on going, right? So we'll do another peg up here. Apply. And apply and okay. Again, this one is still movable. So let's do another flush there and there. And now we're here. So we need another peg. This one and that one. And then let's just get out of this command to get our L bracket. Stick that there. Do another constraint. Here and there. All right, now this is still movable. So let's do another flush. That and that. And okay, and this is also no longer movable. Now we have to put the peg in the back there. So let's get a view where you can see what we're doing. And another insert. This peg into there. Apply. And then the other spacer onto it. And okay. And then we have our kind of like the trunk of an elephant hanging down the front, but still movable, which is not what we want. So we have to do another constraint. Now we could do a flush between these two, but just to demonstrate an angle too, right? We'll do the two-part angle. So we want the angle between this one and that one to be 0. And okay. And we can't move it. And it's always good once you're done to look through, right? All of these pieces should have a black dot, not an open dot. The only ones with open dots are going to be the pegs, right? Because of course the pegs we can spin around and move them up and down or anywhere else, but we could rotate them in place. That's why we don't have the filled out. But all the other ones have filled out circles. We only have one that has a little pin in it, right? That little pin meant that's grounded. So overall, we can also kind of click on it, move stuff around to see if anything moves, nothing moves. We're in good shape.